Welcome to another episode of the Mapscaping podcast. My name is Daniel, and this is a podcast for the geospatial community. My guest on the show today is Matt Hansen. Matt works at Element 84. For the last several years, he has been a key contributor to the stack specification and the development of open source ecosystems for Cloud-Native Geospatial. And Matt is also an AI coder. So today on the podcast, we're talking about AI coding. Now, I don't want to ruin the surprise, but Matt does not have a crystal ball. He cannot see into the future. He doesn't know what's going to happen. He doesn't know what the future of AI coding looks like. But what he does know is that this conversation and others like it need to happen, and they need to happen now. So if you are listening to this podcast episode hoping to find out what the future holds, I'm sorry to disappoint you. That's not what this podcast is about. This podcast episode is about starting the discussion around what we're going to do when the machines write all the code. Hey, Matt, welcome to the podcast. So we've had a little bit of trouble with this recording so far. I think we're on take 3/5, 6, 8, whatever. I really appreciate your patience, and I'm really looking forward to talking to you. And the reason we've pressing forward with this, despite the technology getting in the way sometimes, is because the topic I want to discuss with you is fascinating and really important for the world that we live in. It's all about AI coding and what this means for software development. Perhaps in particular, we could focus on what this means for open source software. So you are the director of Geospatial Ecosystems at Element 84. And I'm wondering if, just to sort of kick us off before we get into the sort of main topic here today, if you could just give me a bit of a understanding of how you got to this position. Like, do you have a background in software development? Did you start life as a geospatial coder? How'd you end up where you are today?
Yes, thanks, Daniel. It's great to be here. So, I have been in this space for a while now. Back in the early 90s, I got my bachelor's degree in photographic technology, which was an exciting time for photography because it was the tail end of photographic film and the beginning of the digital age. Even though digital sensors had been available for that, this is when we were seeing the first sub $1,000 digital cameras in Photoshop version 1. I had to spend some time in the darkroom, study photographic chemistry as well as digital sensors. After graduation, I got a job in intelligence doing remote sensing and then got my master's degree from the same school, Rochester Institute of Technology in New York. And that master's degree was in imaging science, specializing in remote sensing and in digital image processing. So I've been in this space for about 30 years or so. It wasn't until later that I got involved in open source. I was a coder, but I did not really study in school. Actually, it's a bit of a funny story because I took my first programming class as a freshman, and there was 5 of us, and then everybody else was professionals from Kodak, and we were doing C programming class. And I took that class, and I had a hard time with it. I had done Pascal in high school a little bit, but I took that class, had a terrible time of it, didn't understand anything that was going on, and I had to withdraw from the class. So the next year, it was a requirement, so I had to take it again. But I took it in a different program, but it ended up being the same teacher that came over. And so I took it, and I got a D in it. And I was like, you know what? This is it. I'm going to do something else with my career because software is not what that is. And then later, I started learning IDL, which is it's called Interactive Data Languages. It was developed by RSI. It's still around, but it's a high-level programming language. It's proprietary. I would say it's mostly been replaced by Python, so it's sort of similar as a high-level language. And from there, afterwards, over time, I got into C++, Python. I spent a long time coding in C++ and everything, and then started contributing to open source libraries and projects around 2010. GeoNode was the first one I contributed to. So a couple of years ago, I had an opportunity to catch up with that professor that taught me that original class, and I told him that story. I'm like, I took your class twice and thought I was never going to do software. And now here I am, a regular contributor to open source software for geospatial.
Yeah, and not just that. Like I said at the start, you're the Director of Geospatial Ecosystems. Would you mind just sort of telling me what that means?
E84 has a commitment to open source. We use open source software a lot. We contribute to it. We are the main contributors to some libraries that we use. And so I manage our public facing code essentially. So what we maintain, where we put resources into doing that. And this is a relatively new position. So, and in addition to that, I do business development and a lot of outreach and evangelism for open source and open standards. Spent a lot of time, some people might know me because of my work on Stack, where I did develop a lot of the early ecosystem software for Stack and have been involved with it since the beginning.
So, just for the sake of the listeners here, the whole point of this introduction at the start is just to convince them that you are an expert in your field, someone worth listening to. And you've definitely done that. You have a breadth of knowledge within software development and geospatial in general. And I want to say thank you very much for all the work that you've done on Stack and the other contributions you've made to open source projects. It's really appreciated. But now, for the AI coding bit of it, what's your experience with AI coding? What have you been doing?
I think I was a little slow on the uptake. I mean, AI now for coding has been around for a few years. It hasn't been that long, but like moving from auto-completion to like actually like using AI to create whole functions and do more advanced things. But it wasn't until the last year or so that I really dove in because my position, I wasn't really coding anymore, as is what happens when you get a job and get older and move up. You become more managerial. And last year, I kind of got tired of continuing to say that we needed to like put some resources into a library. And I'm like, AI, I just got to do this myself, just JFDI, as they say. And so I picked it up and I started working on a film drop UI. It's a user interface for Stack APIs. And I've worked on a bunch of projects since then. So it's really gotten me, the last year, it's really gotten me back into coding. And I'm not doing it full time, but I've really enjoyed it. I think it allows you to do more and go outside your comfort zone rather than just doing Python. It's like now I can really pick up any project and do a user interface, simple user interface easily enough, or do some DevOps and without having to rely on other people.
I just want to mention before we move on that I really resonate with that ideas in my mind, things I've wanted to see in the world for a long time, but I just didn't have the skills to do it myself. And I can't tell you how exciting it is to live in a world where you can just make the thing. And at least in my limited experience, it's still, you can't just build anything, right? And there are some like catch-22s, and it's easy to get that 80% of the job done. It's that last 20% that has been difficult for me. I can definitely see some limitations, but I got to tell you, it's amazing. I'm loving it.
It's so much fun.
Yeah, it's so much fun. I'd encourage anyone and everyone to get out there and learn these tools and start using them. Not to abandon their skills completely that they've already got. That's not what I'm suggesting. I'm just saying that I think it's worth learning. It's worth understanding to how to use these things. How do you see this affecting? So now, if we sort of broadly say we live in a world where anyone is a developer, anyone can create software. People like me who have nada skills in developing can create software. And if we take that a step further, in fact, we've got tools that are building other tools. What does this mean for software development and perhaps specifically for open source development?
Yeah, so I had the same question, and I saw you in New Zealand at Phosphor-G, and I had given a talk on this. And the reason why I gave that talk is because I often give a lot of similar talks. I've been talking about Stack for a long time, and I kind of wanted to talk about something different. And I was really intrigued by this question. If anybody can build anything, if anybody can just like with a prompt develop any piece of software, what does that mean for open source software? Do people need it anymore? Can I just tell the computer that, tell the AI to create me a thing and it will just create it? And do we need these sorts of shared libraries? Now, clearly, we know that AI is not in a position to quite do that yet. Maybe that's in the future, but that's kind of what I was thinking about. And so it led me down this path to really think about what the impact is going to be on open source software. And I see a danger here. I mean, overall, I think that this is a positive experience, but I see a problem with, I think as a lot of us do, with some vibe coding where it's really not a whole solution. it's a partial solution. And it doesn't handle scaling. It doesn't handle security. I mean, it could do some of these things, but it's not a subject matter expert. And that's what we are in the geospatial world is we're experts and we have this domain knowledge, which I think is really still important. I was concerned that the rise of AI and the proliferation of software and public software out on GitHub could really drown out the signal of these really good vetted libraries and cause a fragmentation in the space where it would get even harder to find good, vetted, proper solutions for software. I don't know what the future holds there. I think there are things that we can do to avoid that. And I think that the role of subject matter experts in this field is more important than ever. And I know a lot of people have anxiety about jobs, but I think that this type of domain knowledge is really where the real value is in our space.
So domain knowledge, you might have heard people say that spatial is special. Is this the domain knowledge that you're talking about? Is this the, I don't know, wall that we can hide behind that will protect us in our jobs?
No. In the long run, no. I mean, I don't think so, right? Like AI will get better. I don't know when that is, but we do have to admit, this is a bit of an aside, but we do kind of have to admit that technology is always about working yourself out of a job, right? Like ultimately, you're going to become obsolete and you have to learn new skills. And it's not that the jobs are all going away. They're just shifting to other types of jobs. So software development as a job 20 years from now, no one's going to be writing Python code anymore, but we'll still be designing software systems and computer systems, just not by writing code. So the geospatial isn't special has been a movement, a message in the geospatial community for a long time. And the idea being that we need to integrate the understanding of geospatial technology, data, coordinates, that sort of thing in general purpose software. So GeoParquet is a perfect example where Parquet is a well-known file format. And rather than having a separate file format that's GeoParquet, the push was to get a geospatial as a data type, just like any other data type, into Parquet. And we've seen that all over the place. Let's push geospatial as a data type and not have it be a unique thing with its own set of libraries and everything, but rather push it into the standard ecosystem of software tooling, which has worked really well. However, what I think that we've seen is that geospatial is special because when you ask an AI to do something, it still does not necessarily understand all of the edge cases and understanding of geospatial data types that it needs. And we see that in anti-meridian handling as an example. There's a library called Anti-Meridian that Pete Gadomski wrote over at Development Seed. And that handles all of these edge cases of handling polygons that cross the anti-meridian. But if you don't know about that library and you're just vibe coding something and you're dealing with polygons, the AI is most likely not going to use that library. And instead, it's going to just create a solution for your data. And it does not see all of the wide variety of data. And so it's going to create something that I guarantee is going to fail under real world conditions. It doesn't really understand the geospatial data, not right now. And so in that sense, geospatial is still special and still requires, I think, domain knowledge.
I have a feeling that this is what you're talking about when you talk about fragmentation. So you just mentioned that the AI would go ahead and create like a custom solution. It would think through and do something as opposed to standing on the shoulders of giants using software packages like what you just mentioned. It would just create its own thing. Is this the fragmentation bit that you're talking about where tried and true tested pieces of geospatial software get lost in the noise?
Yeah, exactly. I think that the AI is going to default to creating often bespoke implementations unless it's directed not to. So if you have, and this is why if you have that domain knowledge and you're using AI, then that's great. You can direct the AI to use specific libraries and go about doing things in a certain way. But if you don't know about these things and you ask AI to do this, it might not actually know which libraries to use. I think there are some things that we can do to mitigate that, but that's essentially it. So you're creating a bunch of different solutions, a bunch of fragments of code, thousands, and if they're released into the wild, like put out as public code on GitHub, then we are really creating a sea of noise, because it'll make it harder in the future for AI to find the actual proper solution among all of these vibe-coded fragments.
This is kind of the same problem that Google has been addressing for years. And hear me out just for a second. Its job is to surface the best answer to your question. And so this is where the world of search engine optimization has sort of grown up around. Like, how do we optimize for that? Its backlinks tell Google that the more sites that are referring to this particular site, this particular source, I mean, that gives Google an idea. Oh, lots of people are talking about this. Oh, lots of people spending time on this page. I can see this particular piece of software, this particular code is being referenced here, here, and here, and people are integrating it into their solutions. So I guess, do you think this problem is just going to solve itself? Like, will AI just figure this out?
Maybe it will. And eventually, that seems likely that it'll get better at it. But I don't know, some days when I'm working with AI, I really get to the point where I'm convinced that there's no way that this thing is ever taking my job. I don't know if you've experienced that.
Yes,
But, you go through phases when you're using it where you're like, this thing is amazing. What am I'm useless. Like, why am I even here? And then you get to the valley of despair where you're like, oh my God, this thing is so stupid. It can't do anything right.
Yeah.
So I don't know. I go up and down about it.
Yeah, me too. And in my microscopic little experience with it, I found that I need to do exactly what you said. Tell it, like, I would like to use Leaflet. Do not create any custom tools. Only use standard libraries and functionality that are in this. Be very, very specific. But getting back to our problem of fragmentation, let's assume we're proactive spatial professionals and we don't just want to wait and hope and pray that it all works out. Proactively, what can we do? So perhaps better documentation. People could think about quote unquote marketing, like solutions that work. The community could support certain solutions in a lot of different ways, I think, and sort of make it clear to the machine that this is something that all of these people believe in and are using. Do you have any thoughts around like what we can do to avoid this?
Yeah, I think you're right on about the documentation. People are listening and they're probably like, great. All they're doing is telling me to write documentation. Like,
Yeah.
people have been telling engineers that for years, right? Like, come on, write a better README at least. Give me some tutorials. But it's true. I think at this point, especially since AI is actually really good at writing documentation, although with some caveats, I have spent a long time trying to get AI to write really good documentation, but it is helpful. I don't think there's an excuse for a bad README or a lack of tutorials or a lack of documentation in any open source library. And so one of the things that I will be doing over the coming months at E84 is improving how we present open source code, because there's no excuse for that. Like, you can do that. You can clean up your README really easily. And this will help improve that signal, right, among a lot of other code. It turns out that the things that make using code easier for humans also make it easier for machines to use them as well. And so you kind of get two for one. You have a library now that's better understandable by developers, as well as the AI's machines that they're using.
Yeah, but I mean, that makes a lot of sense to me. And AI, as you said, is here to help us with that. What would you think about the idea of just creating like a giant markdown file that said a list of software, and people could just go and get this list of software, use this software? These are community vetted pieces of software, if you will.
Yeah, I mean, that's probably a pretty good idea. There are lists like that, right? There's awesome geospatial, and like there's various indexes online of that sort of thing. And maybe what we need is a big meta prompt that includes all of these things that we can feed into the AI to become a geospatial expert. Here's the geospatial expert developer prompt, something like that. I will add there's another thing too. So there's documentation. That's kind of what we can do right now. But the another thing that's super important, I think even more important in the age of AI, is standards. Standards are really critical. And I think for obvious reasons, right? It's like the AI is going to be able to interface with standard APIs a lot better with less error if there's a single standard that's well documented and there's implementations of that standard. Like take Stack, for example. If we didn't have Stack and you wanted to use AI to develop some code to search for geospatial data, then first off, you'd have to tell it what data, you'd have all these different APIs. It might not necessarily understand which fields correspond to other fields that are named different. And so you end up with a lot of extra code having to deal with all of these bespoke things. You have to have all these different drivers, for lack of a better word, to interface with them. And there's no existing software necessarily to interface with them. So you have to create that from scratch. Whereas with Stack, we have one standard. The AI can understand that standard. You can have it read the spec. You can point it to implementations, and all of those implementations are going to work the same. They'll still support the same core features anyway. And so I think going forward, standards are absolutely critical in having AI be successful.
That makes perfect sense. Getting back to my idea of creating a giant text file, a meta prompt, as you put it, could we also take that one step further and have standard pieces of software? I think we already have this, but is there something else we could do? We talked about these indexes online, Awesome Geospatial. I know of a couple of others that perhaps I can try and include in the show notes here. But is that really where we're headed? Like, so standards, these are the way these software interface with each other is important. And here are the standard packages that are vetted.
I don't know. I know I say that a lot. My wife says I say I don't know way too much because I don't. However, in the future, I mean, I don't think that still seems a little low level to me, right? As we move from becoming developers to more just interacting with AI systems and designing software, I say that this is kind of like moving from software developers to software designers. And so I have promoted this idea of the foundry, and it's not really a specific thing. It's just I needed a term for this. And the foundry is essentially, I think it's a collection of specifications. So if you're familiar with GitHub Spec Kit, people have been vibe coding a long time now for a couple of years. And now I think there's been a bit of a push towards more rigorous specification and how we do that, rather than, oh, I'm just going to explain to the AI what it is that I need. GitHub Spec Kit is a process. It's a formal process for describing how we define the constraints and the requirements for software, which very well might be the future, or something like GitHub Spec Kit. That might not be the answer, but I think it might be something like that. So we're essentially going to be defining blueprints, but they'll be in human language rather than a programming language.
That makes a lot of sense. Do you see closed source software having to deal with exactly the same issues as open source software? Is this just a problem across the board, do you think?
I think it is a problem across the board. I wonder about the future of proprietary software as well. If anybody can code anything, in most cases, in a lot of cases anyway, open source is kind of won, right? 30 years ago, it was an experiment, but now Linux runs the world, right? And so I wonder if this is going to accelerate a decline of proprietary software, except for niche use cases, which is, I mean, that's where we still see proprietary software is more really small niche use cases in industries. Would you agree?
Yeah, I would. I guess it depends on what level we're talking about, but I definitely see the argument with Linux has won the world, right?
Yeah.
It really has. It's hard to compete with that. I also wonder about instead of talking about closed source software, if we're going to be talking more about sort of personalized software. So if people creating their own stuff, I can see that also eating into the closed source software world, because Why is it exactly I should pay 40, 50, $100 subscription a month when I can just build my own thing? Where it's not one size fits all. I made this thing exactly for me. And sure, maybe it's not as pretty, but if it's just for me running on my local computer and I don't need all these security bells and whistles around it, yeah, I can see that being a real competitor to a lot of niche pieces of software.
Right, because proprietary software has a lot of features, right? And think about any software that you use, you're never using all those features. You're only using a small subset. And so, yes, it's a good point. I can create exactly what I need. And especially if I have that domain knowledge and I want to create a user interface for a mapping interface for something, I can create it for my specific purpose. And I don't have to worry about making it general or necessarily even making it usable by others because it's relatively a low lift to make it. And so, of course, that will feed more into fragmentation. There'll be like just lots and lots of different packages out there that actually aren't really all that usable by anybody other than a small handful of people. And I think that's okay.
Yeah, I can definitely see that with the fragmentation side of things, especially because you mentioned it's such a low lift to make. So why not have like 500 iterations where before you would have had 2 iterations of this thing? Why can't you push a new change every hour? You know what I mean? Until you get it right. That would be the temptation, I think, for a lot of vibe coders. Why not? I didn't get it right. Just do it again, do it again, do it again. Have the machine do it again.
Yeah. Yeah, exactly.
Hey, so you mentioned this idea of moving from software development to being a software designer. How do people prepare for this? Let's imagine for a second you have a daughter. She is totally committed to the idea of being a software developer, but we're steering into a world of AI writing the vast majority of the code in the world. What's your advice to her? She's in her last year of her university degree.
Tell her maybe she should do something else. Maybe. I don't know. It doesn't seem like there's a lot of unemployed computer science graduates right now. But we are talking about geospatial here, but I think that domain knowledge piece is applicable in a lot of different other areas. I think that's the play. That's the value that you bring is that general computer science background and learning about like registries and low level computing. Like it might be interesting. It might be useful to know, but it's not really going to be helpful in your job. But that domain knowledge will be. And so I think that's what I would focus on is don't be a generalist, be a specialist in something. And I would tell her to do geospatial because it's cool.
Absolutely. Yep. We agree 100% on that. It sounds like a bit of a chicken or the egg problem. Like, which comes first? Like, do you become a software engineer and then get domain expertise or vice versa? And also, in leading on from that is, can I be a software designer without having that sort of experience of being a software developer?
I think you can, but well, at this point, I'm not sure if that's really true right now. I'd be interested in like how far people who don't have software experience take vibe coding, like without really knowing what a programming language is or what a compiler is, like without knowing any of that stuff, like how far they can really get. Because when I'm using it, I don't see how somebody that doesn't have some basic computer developer experience, how they could manage. I don't think that they would know enough.
Yeah, yeah. That being said, it has been surprising how quickly this has developed and how quickly it has improved. And I know from the podcasts I listen to, the big labs are racing towards this idea of recursive improvement. That is their focus. And I'm not saying they'll get there today, tomorrow, maybe even this year. But when they do get there, yeah, that's we're going to see a lot of improvement really quickly.
Yeah, I saw this Ralph Wiggum script yesterday. I don't know if you saw that. The listeners can look up the Ralph Wiggum script, but somebody essentially it's a loop and it's using Claude code and it says create this thing and then whatever you get for the output, feed it back in and just continue to do this over and over until it's done.
It sounds like a brute force way of doing it, but tokens are getting cheaper and cheaper. So, and if you don't know anything else,
Yeah.
why not? Why not just brute force your way into it?
Yeah. I mean, it might end up being expensive over time, but again, as you say, it is getting cheaper. Yeah,
But I guess my question is expensive compared to what? Because it's probably not going to be as expensive as hiring a developer.
that's true. Yes. Developers are expensive. We're seeing that, right, with the layoffs and
Yeah.
difficulty in getting a job as a junior programmer.
How do you think we're going to end up with senior programmers in like 10 years' time?
That seems like that's a problem, right? We're really killing our pipeline here.
Yeah.
I mean, at E84, we're a services company and we're primarily a senior organization, right? Like we're mostly made up of all experts and senior level developers. Because if you're going to hire a firm to do software development, like you're hiring them for their expertise. You don't necessarily want to get stuck with a junior engineer who's just somebody you could have hired yourself. So we don't hire them. And I think that other places are also moving towards that and clearly hiring fewer junior engineers. So yeah, so 10 years from now, this is going to be a cycle probably where even though people won't be programming, there'll be a dearth of experienced developers and there'll be a call to send people back to school. And
Hmm.
we need more computer science people or AI software designers or whatever it is that they're called, whatever that job of the future is.
Yeah.
I don't know. I'm just making it up as I go along here. I mean, I don't really know.
Yeah.
But I want to talk about it. I think it's great to talk about this. And I really had fun at Phosphor G talking about this with other people and seeing their thoughts because I don't claim to really know what's going to happen, but it's an interesting ride.
Yeah. And of course, you can't see into the future as none of us can see into the future. No one has that crystal ball. I think the only mistake we could make at the moment, to be perfectly honest, is not talking about it, is sticking our heads in the sand and pretending like it's not happening. I have seen a tendency for this to be quite polarizing where people are like, it's the way forward. Like, throw your keyboards away and just start talking to your computer. And other people have jumped over on the other side of the argument and they're like, this is crap. It is just a fancy autocomplete. It'll never take our jobs. And I don't see how either of those two arguments are ultimately really helpful. And I wouldn't stand on either side of the fence personally. I don't even know if I'd partake in that conversation. I would just be quietly learning how this stuff works, seeing where it benefits me, where it doesn't, where it falls over, where it succeeds, what I can replace. And I'd just be sort of quietly moving forward with this. But it is really interesting to see how people react to it.
We can look at history, right? As an example. In the 1950s, there were assembly programmers. And Kathleen Booth, she wrote the first assembly language. That was some really arcane knowledge, right? It was like a priesthood of assembly developers. And when the compiler came along, right, they had all these same arguments that we're hearing today. And they probably sound familiar, right? The compiler is untrustworthy. How can I trust that it's going to do the right thing? And I can beat the compiler by hand. I can write assembly language and it's going to be faster and better than what the compiler can do. And this sounds exactly where we're at today, right? We're hearing the same things. How can I trust the AI's code? And I can actually do better. I can write better code than the AI by hand writing it. But that's not the point, right? The point is that the compiler was good enough to allow us to take on more things and do more and move up the stack and move from writing really specific code for like certain architectures to writing code that could be ported and deployed all over the place. And now we're seeing that same thing. This is going to allow us to move up that stack and move away from writing these languages and do more and write more software and have it be more productive and be able to take on more and more complex things.
I think you hit the nail on the head there when you said good enough. I think a lot of people, when they say that AI is never going to be able to do my job, I think they're arguing for perfection.
Right.
But I don't think in a lot of use cases we need perfection. I think we need something that is just good enough. If it comes down to costs, like, are you going to pay for X for perfection or get good enough that's going to work today for significantly less, I think that good enough is going to win.
Absolutely.
Hey, Matt, this has been fascinating. I really appreciate you coming along and I don't want to say sticking your neck out, but like starting the conversation. I realize that, again, you don't have the crystal ball, you can't look into the future, but I appreciate your insights that are based on years of experience. And just starting this conversation, I think, is the really important thing. So thank you very much. I appreciate it. And I want to say, despite you coming on my podcast and talking about documentation and standards, you're welcome back anytime.
I know. And thank you, Daniel. Thanks for having me. Yes, standards, I always thought were pretty boring. Like, how did I get into this? But really, I used to do algorithm development and remote sensing stuff. And then I got into standards. Never thought I'd do that, but it's so important and it's needed to do the cool stuff. And so that's why I ended up there.
Yeah, I totally appreciate that. I will put links in the show notes to your presentation at Phos4G. I think that you have a few blog posts coming out in the next little while. They might even be published at the time that people are listening to this, and I'll try and link to those in the show notes as well so people can sort of follow up on this if they like. Again, thank you very much for your time. You are welcome back next time you have something interesting to say.
Fantastic. Thanks again, Daniel.